By the end of this session, you'll be able to calculate kinetic and gravitational potential energy, describe energy changes in a mechanical system, and also state the principle of conservation of energy. If we think about the different types of energy that you've come across, that you wrote down, gravitational potential energy, light energy, chemical energy, elastic energy, kinetic, sound, heat or thermal, electrical energy, there's a whole range of energy that we're used to. But if we think about the types of energy, they basically come down to two forms: potential energy, which is stored energy, and kinetic energy, which is movement energy. We'll think about each of those individually. So let's start with kinetic energy. Kinetic energy, if we want to calculate it, is given by this equation, half mv squared. The units of energy are joules, mass is kilograms, and velocity is meters per second. Now what do I mean? Everything can come back to kinetic or potential energy. Well, let's think about a windmill. If we look at a windmill, the wind, because it blows the turbine blades spin, which spins a generator, which produces electricity. Think about that. The wind is blowing, the wind is moving. The turbine blades move to produce electrical energy. So everything, all the energy changes are basically kinetic energy. It's all about motion. So wind energy is kinetic energy. Wave energy is kinetic energy. And we can look at lots of types of energy and see that basically they're kinetic energy. What about potential energy? Well, potential energy is any form of stored energy. So we have chemical potential energy, for example, in batteries or in fuels. We have elastic potential energy in stretched springs. We have gravitational potential energy in objects that are high up. Now, the one that we mostly look at in physics out of those types of potential energy is gravitational potential energy, and we'll have a look at that next. So, gravitational potential energy, that's the energy an object has when we lift it up. It's the energy due to a gravitational field, and we calculate it using this equation: mass times gravitational field strength times the change in height, or mgh. Again, energy is measured in joules. Now, the important thing to notice about gravitational potential energy is that it's not an absolute, it's a change in gravitational potential energy. We can define our zero of gravitational potential energy anywhere we like, and so because of that, it's changes in height that we're interested in, not absolute height. Now, on Earth, we use the ground as the zero gravitational potential energy, but when we come on in A2 to look at questions involving the gravitational fields of planets, then we have to be careful where we choose our zero of gravitational potential energy. Now, one place that we often see energy changes between gravitational and kinetic energy is on a roller coaster at a fun fair. In a roller coaster at a fun fair, you're winched up mechanically, but then everything else on the whole is powered by gravity, we say. So we have gravitational potential energy, and when you're released, your gravitational potential energy is transferred into kinetic energy, and that gives you your velocity. Now, we can use the idea that gravitational potential energy can be changed to kinetic energy to calculate some questions about roller coasters. Have a look at